Hello everyone, welcome back to physics class. So today we'll discuss about Newton's third law of motion. In the last class I gave you a little bit introduction about Newton's third law of motion. Simple statement is every action force has equal and opposite reaction force. Statement looks very simple but it has much more implication. Now just look here. Let's say you have an object A over here. This object A, assume is exerting a force on this object B. This force I am telling as action force. So this object B, it will exert same amount of force on object A, but in opposite direction. As you can see, this is in this direction and object B will exert force on A towards A. So this is your action force, this is your reaction force. But the important thing to remember here is this action and reaction force. They act on different objects. It is very important to remember this. Now why? Just imagine what will happen if this force acts on same object. Then there will be no acceleration, no change in velocity, no acceleration. So there will be no acceleration in this world, nothing will move. So this force implies on two different objects. Now, one more thing that we have to keep in mind. Forces, action and reaction forces, they are equal and opposite. So, does that mean if I apply force on any object, then that object will apply same force on me? Then, some objects accelerate more, some objects accelerate less. Why? Because though I am saying magnitude is same, but this force depends on mass of the object. A very small example you can take. See, I have these two things in my hand. One is this cap and one is this pen. This cap has less mass as compared to this pen. Now, if I apply same amount of force on these two objects, let's say they are on ground and I apply some force. So, which will move faster? Obviously, the one having less mass. So, though I will apply same force, depending on mass, they will accelerate. So, the effect of force may be different, that will depend on mass of the object. But forces, they are going to have same magnitude. Okay. Now, few very common examples that you can see in your daily life. One is example of jet engine. If you know the jet engine or rocket also you can say, this is the exit point, the exhaust gases come out of this point. Now, this is action force. The reaction, it will act in opposite direction. So, as a result of this reaction force, this engine or this rocket will go in up direction. The second example of bullet and gun. When I shot a bullet from a gun, you can see this gun exert a force on bullet and it goes with very fast speed, fast velocity in forward direction. In turn, this bullet also exerts force on gun, same amount of force, and this gun, it gets a little bit recoil. Recoil means it little bit moves back in backward direction. Now here you can see bullet, it goes with very high speed, but this recoil, that is reaction force. Effect of reaction force here is very small. Gun recoils very little, very small amount, in very small effect can be seen when it goes in backward direction. Why? The difference here is in mass. Bullet is so small, so light, it gains high speed from that force. And the same thing, this gun, it receives very small amount of effect from this reaction force. One more example, let's say a person is jumping from a boat. So what will happen? Maybe you have faced this situation many times. So what will happen? This force, it will move in backward direction and the man jumps in forward direction. So here also you have pair of action and reaction force. No matter any one you can tag as reaction or action force. But here the two objects, one is man, one is this boat, action in this direction, reaction in this direction. They are opposite and equal. The difference because of mass of this man and boat. One more common example that I told you that day, I am standing on the ground, I am exerting my weight, I am exerting some force on this ground and this ground, earth is also exerting some force on me. And as I am saying, the Newton's law, they are same. But can you see see Earth accelerate? No, you cannot. Why? Because Earth is so massive. Its mass is so much bigger as compared to us. So that is acceleration that we are giving to Earth is negligible. That's all for today. Thank you.